In this video, we will be presenting our research project that investigates chart content accessibility beyond alternative text and tables. Nowadays, data visualizations are widely used by people across different disciplines to better understand and communicate data on the web. Like sighted people, blind and low vision people also encounter data visualizations in their lives as they use screen readers to browse the web. This issue is further compounded by the complexity of modern interactive data visualizations. The inaccessibility of these visualizations is a well-known problem. Our text does not support data exploration. Data tables strip away the benefit of data visualization. Often the issue is beyond individual responsibility because many data visualizations today are produced using charting software and programming libraries. However, it is unclear to what extent these tools support accessibility. Our research question is twofold. What accessibility features do visualization tools offer beyond? What are the existing accessibility strategies for chart content and how do they compare? We tackle these questions through a two-phased investigation. First, we analyze the accessibility of existing visualization tools. Next, we compare chart content accessibility options to explore how these tools can be more accessible. Let's first take a look at the first part where we assess current accessible design support. We compiled a list of popular visualization software and programming libraries through a systematic web search. Since the web is the primary channel for information consumption, we focused on web-based visualizations. We excluded internal analytic tools and low-level graphic libraries. We collected 30 programming libraries and 9 visualization software in total. We conducted a systematic content analysis, inspecting the accessibility features and resulting visualizations created by the tools. Here is a table that shows an overview of the analysis. The tools are listed on the horizontal axis. The dimensions of the analysis, such as alternative text and keyboard navigation, are listed on the vertical axis. Overall, we categorized our findings into 5 main themes, including accessibility statements, standard accessibility methods, and keyboard navigation. It is encouraging that several tools often provide accessibility statements. Often, these include detailed compliance reports on how well they satisfy accessibility standards. Since many of these tools are used by government agencies, they are required to ensure that their tools are accessible. A few tools provide documentation and guidelines for creating accessible visualizations, which we observed during our analysis. However, we found that a majority of tools do not even support alternative text, as evidenced by the many empty cells in the table. Alternative text was often automatically generated using available data. Some tools allow for customization of the generated text. Support for tables is even lower, but some tools offer data exports. Not all but a few programming tools support keyboard navigation of underlying chart content. There was no consensus on how to make chart content accessible, but most tools supported multi-level navigation to varying degrees, for instance, starting from alternative text and progressing to data series and data points during keyboard navigation. Only a few tools allow customizing the order of navigation, such as through tab index or an order array. Some of the tools provide label customization, often using data to generate and customize labels programmatically. Among software tools, only PowerBI supported the keyboard navigation of chart content. Highcharts was the only tool to proactively announce dynamic data changes. It also provides a threshold option to disable navigation when data is too large. Some tools offered low vision support, such as pattern fields, high contrast palettes, and focus point highlighting, but these features were not widely supported. Highcharts is the only tool to support sonification and voice control. Flourish offers voice narration over the chart. In summary, our findings showed that existing visualization tools still lack basic accessibility features, such as alternative text and data tables. However, it was encouraging that some tools supported keyboard navigation of chart content. Although there was a trend toward multi-stage navigation of chart content, there was no clear consensus on how to make chart content accessible. This motivated our second part, in which we explored existing options for chart content accessibility. We investigated 2 recently proposed ideas, structured navigation and conversational interaction. Researchers recently proposed a structured navigation approach that decomposes a chart into a hierarchical representation. The root contains alternative text, while the next level includes visual encoding nodes such as axes or legends. One level deeper, users can explore data categories, and at the bottom of the tree are data points. Users can move across different levels of the hierarchy using up and down arrows. They can move across subtrees or data points using left and right arrows. In contrast, the conversational approach involves natural language interaction. Users ask questions about the chart and the system provides answers. The original system was limited to single series data, but we extended it to support multiple series data for our study. The goal of our study was to contrast pros and cons of these methods against data tables as a baseline. After a series of pilots, we had a final set of 21 participants. There were 12 female and 8 male participants, including 15 JAWS users, 3 NVDA users, and 2 voiceover users. Of these participants, 14 had an advanced level of screen reader expertise, 5 had an expert level, and 1 had an intermediate level. Our study used a within-subject design. We began with a demographic survey, followed by 3 randomized blocks. The blocks represent 3 experimental conditions: table, structured navigation, and conversational interaction. Each block started with a tutorial introducing the corresponding accessibility method. Next, the main trial presented a randomly selected chart from among the 4 available chart types. After each trial, a post-task survey asked participants about their experience with the method. Finally, a holistic post-study survey compared all 3 methods. In the main trial, we asked 7 different questions, including 2 extrema, 2 comparison, 2 summarization, and 1 insight question. All questions were multiple choice, except for the insight question, where participants were asked to summarize the main takeaways of the chart. Let's first take a look at the past performance result. The accuracy of responses to the multiple choice questions was significantly higher for conversational interaction and data tables compared to structured navigation. Similarly, participants had significantly faster response times with conversational interaction and data tables compared to structured navigation. We found no significant effect of screen reader expertise on the experimental results. Similarly, we found no significant difference in accuracy between the different chart types. However, we observed that participants had faster response times for the map chart, which may be due to its use of single series data. In addition, the bar chart had significantly faster response times than the scatter plot. For the insight question, we used a 5-point scale to rate the quality of the participants' descriptions, with a score of 1 being the lowest and a score of 5 being the highest. For the insight question, we found that participants using structured navigation provided significantly higher quality descriptions compared to the other methods. Next, we will present the results of the participant preference survey. The results of the participant preference survey generally align with the task performance results. Each graph displays 3 lines, with the conversational approach in the first, structured navigation in the second, and data tables in the third. A blue color indicates greater participant preference. The first 2 questions of the survey asked participants to rate how enjoyable and easy to use each method was. As shown in the graph, participants favored the conversational and table approaches for both questions. When participants were asked about the usefulness of each method, they once again expressed a preference for the conversational and table approaches. We also asked participants which method was easier to work with when they already knew which information they were looking for. The trend in responses was consistent with the previous questions, with a preference for the conversational and table approaches. When participants didn't know which information they were looking for, they indicated that the table approach was the easiest. When participants were asked how confident they were about their answers, the majority chose the conversational interaction method as the most reliable. However, some participants' comments contradicted this trend, and we will share these comments in the next slides. Next, we would like to share some of the observations and comments made by the participants. We categorize the comments into 4 categories. First, we will share some comments related to participants' preferences for the conversational interaction and data table approaches. Participants tended to prefer the intuitive and interactive nature of the conversational interaction method, which allowed them to use natural language. On the other hand, participants appreciated the freedom and control provided by data tables, as well as their familiarity with them. However, participants also mentioned that data tables can be difficult to navigate for large data sets. Regarding structured navigation, participants frequently mentioned their unfamiliarity with and the complexity of the hierarchical navigation layout. However, some participants still appreciated structured navigation. For example, P26 mentioned that it presents the most realistic depiction of the chart. This is in line with our result for the insight question. Conversational interaction had its limitations, particularly in terms of the gulfs of execution and evaluation. Similarly to other natural language interfaces, users encountered difficulties in determining which commands to use and in assessing the accuracy of command recognition. The conversational interaction approach also lacked the clear picture of the chart that the structured navigation provided. Participants experienced frustration with repetition and recall across all methods. They expressed frustration with having to recall the task questions while exploring each method, which imposed a significant cognitive burden. The complexity of the data also contributes to the cognitive load problem. It's worth noting that in our study, the data used was still relatively small compared to what is considered large data. These frustrations often yielded to ill-formed assumptions about the chart, which could negatively impact their task performance. In other words, they did not frequently refer back to the chart to confirm their assumptions. This was a common phenomenon across all participants. Based on the lessons learned from the study, we would like to provide some guidelines for future accessibility approaches. We recommend keeping data tables as the default or fallback method for accessibility. People are familiar with them. They are well established for screen readers. One thing we learned was the difficulty in ensuring detectability. Participants used varying keyboard shortcuts, screen readers, operating systems. They also often used custom software or extensions that could potentially conflict with the accessibility methods. Another thing we learned is that we should explore ways to provide better affordances and feedback to support greater autonomy for users. Specifically, we need to study onboarding methods and non-visual cues that can convey how to execute and evaluate speech commands. Further investigation is necessary to explore custom options for controlling the amount of information delivered through screen readers and improving the orientation of the navigation in structured navigation, as some participants were confused by the current vertical tree structure. We hypothesized that their pronounced tendency to rely on prior knowledge and attempt to guess the answer might be their coping mechanism. Instead of preventing it, leveraging it in some unbiased way to reduce cognitive load might be beneficial. Finally, our study emphasizes the distinct advantages of each of the three approaches. Instead of selecting a single optimal solution, it would be beneficial to integrate the benefits of all methods to support multimodal interaction. Thank you so much for listening. You can find more information about this project and other related projects in the research group website.